Welcome back, you guys. In the last video, we just finished overloading the equals operator and the double is equal operator, as well as the not equals operator. And here now, I want to be able to have a statement like this. So we're going to work on overloading the double angle brackets operator for both cout and cin. So how this is going to work is going to be just a little bit weird because I'm going to be introducing the concept of the friend function. I'm also going to be talking about the data type of cout, which is OStream. So things are a little bit more complicated here, but don't worry, as I fill out the code, everything will start making more sense. Well, at least I hope they will. But here we're setting up our inputs, and we're going to be, I'm just going to keep it as a semicolon. Well, let's do that. I'm going to do something like this, and here's how we'll go about it. So now let's kind of take this apart. Let's start with the friend keyword. So as I overload this operator, this isn't exactly part of the class, just like overloading these operators are part of the class. When I'm doing something like this, it is outside of the class. And I need to do this because I want to access the contents of P through the output stream that I'm creating, which leads us to the next thing that I want to talk about, which is StandedOstream. StandedOstream is the data type of StandedCout. So when I create StandedCout and I add things to the output stream, I'm adding them to the StandedOstream. So I need to include this because, let's say, for example, and actually let's go down to main and see what I mean, why I need that OStream as an input argument. Here I have StandedCout, which is an OStream data type. So it's going to take, when I have this angle brackets, double angle brackets here, here's going to be my 0.3D, and what came before these two double angle brackets is going to be my OStream. So right now only StandedCout is added to the OStream, and then I add A, which is going to be a point. And then I continue my OStream where I add a character, and then when I reach it again with the 0.3D class, when I get here, when I call that overloaded operator, I get the OStream of everything that was called before it and my current class 0.3D. So what I'm trying to get is that we need this first output because I don't know what's going to be in the output stream before my point P. And I need to return this same variable to the output stream because I don't know what's after, right? So the idea here is that I want to add 0.3D smoothly to the output stream without causing any trouble. So I gain an input that's the output stream, and I'm going to return the output stream. So here is how I'm going to add 0.3D, specifically P, to the output stream. So since out here is a StandedOstream, it's like cout. I can use it just like cout just because it's the same data type. So I use out like cout, and I use the double angle brackets, and I load all my data here, right? The X, Y, and Z values of P, I use the getters and they're put here and they're added to the output stream. So now that they're added to the output stream, I need to return out so that way whatever's going to be in front now until the end of the stream, I can continue adding it to the output stream. And similarly, when I do the same thing with how I want to interact with StandedCin, I'm going to have an input stream and I'm going to have these values that are added to the input stream, and I need to set them equal to the members inside of 0.3D. So why don't we see how we can implement that? Again, like the other operator with the double brackets for cout, for cin, it needs to be a friend function. Just because StandedOstream and StandedIstream, they are different data types that are trying to gain access to our class here, so it needs to be a friend. So when it's a friend, it means that, well, we can access the private data. However, here I'm not exactly exercising that just because I like to use my getters and setters, but in theory I could use this with no problem. And actually, for the time being, we'll keep it this way, just to show that a friend function, when you have a friend function, we're able to get, StandedOstream is able to get access to the private data of point3D, because with this announcement, we're announcing that, hey, in this body of code, in between these two square curly brackets, it's going to be a friend of point3D, and it's able to access the data, the private data, with no problem. And we're kind of doing the same thing here. And just because I'm adding additional constraints to what I want to set my value to, I'm going to be using setters. But if I didn't have that restriction, the same thing, I could just access the private data directly, because in between these two curly braces here, StandedOstream and in, they're going to be friends of the point3D class, and they're going to be able to access the private data of the point3D class because they are friends. Anyways, let's talk about the double angle bracket operator for stdcin right now. And it starts off with friend, which we've just discussed why we're having it here, and StandedOstream. So like StandedOstream is the data type for stdcout, StandedOstream is the data type for stdcin. And we follow the same principles as we did with StandedOstream. Here we have a pre-established input stream called in, and we're going to take point3D with a reference to P. So I don't have the const here. The intention here is to modify P, right? With the input stream, we gain an input, and we use it to modify P. So what I do is that, and I do this specifically because every single attribute of P is a double. So I create a temp, so I read the first number in, and then I set X. I read the second number in from the input stream, and then I set Y. I read the third number in from the input stream, and I set it equal to Z. And as a result, everything that I got from the input stream now has been filled in for P, and I'm good. I don't need to use the input stream anymore, so I'm going to return in, right? Because just like OStream, if I'm establishing an input stream, I need to keep that stream going. So now let's go to main and kind of see how this is going to work. Here we have the output stream. Why don't we look at an input stream? So why don't I set the values equal to, I don't know, let's say Q. So here on lines 181 and 182, I have the cin, which is going to read in the 3 values, and the cout, which is going to print all the values. So with that, why don't we see the results of this program? Let's see if this works. So this is a good sign here. I know that I'm using the stdcout because I don't have, here's the print function, right? And here's how it looks with stdcout. So I know it's following that behavior correctly. And then now I know that I established an input stream because this program is waiting for an input. So why don't I do something like 537, and we see our input. This is a little wonky because this is supposed to be on a new line, but here we have our read in class. And we overloaded the double angle brackets both for cin and cout to get this result, right? And we're essentially telling our compiler, here's what you do with the class when you encounter this operator. I want to highlight that we're adding additional functionality. We're not taking any functionality away from those operators than what's already there. So if I have another class overloading this operator, that's okay because I'm adding additional functionality. I'm not taking away anything from these operators when I overload them because I'm adding more functionality. However, with our success of the program, I think we're going to be at the end of the video. In the next one, I'd actually like to cover one more set of operators to overload just because it's a little neat, and it's going to be the plus plus operator and the minus minus operator. And I'll be showing you the difference between a post plus plus increment and a pre plus plus increment, as well as the same thing for minus minus. So I'll see you there.